As SpaceX gears up for the next launch of Starship, exciting details about its flight profile and specific mission plans are emerging. One notable update is the inclusion of a propellant transfer demonstration during the third flight. This milestone represents a significant step in Starship's development, and will require the vehicle to successfully enter its coast phase as it circumnavigates the globe. Not only does this demonstrate progress towards Starship's lunar lander capabilities, which have been a recent topic of concern, but it also signifies an important advancement in propellant transfer technology. It's worth noting that, while the propellant transfer plan for the upcoming flight is relatively straightforward, future plans involving multiple vehicles in orbit will undoubtedly be more complex. Let's delve deeper into today's episode of the next flight's plan, the propellant transfer process, and the progress of the vehicle itself. On the upcoming test flight of Starship, SpaceX and NASA might be taking a cautious step towards orbital refueling. However, it's important to note that NASA officials have not yet made a final decision on when they will begin showcasing the crucial cryogenic propellant transfer capabilities required for lunar missions. NASA is particularly enthusiastic about demonstrating orbital refueling technology, as it holds the potential to establish propellant depots in space. These depots would serve as a vital resource for rockets venturing beyond Earth's orbit towards far-flung destinations. In fact, NASA had previously announced partnerships with 4 companies, namely Lockheed Martin, United Launch Alliance, SpaceX, and Eta Space, a startup based in Florida. These collaborations aim to validate the capabilities of refueling and propellant depots, using cryogenic propellants. Cryogenic fluids like liquid hydrogen, methane, and liquid oxygen must be kept at extremely low temperatures to prevent them from evaporating. Currently, the International Space Station is refueled with room temperature propellants, but rockets using super cold propellants have limited mission durations. NASA and industry engineers are working to extend mission durations by developing technologies to maintain cryogenic propellants at the required temperatures. Propellant transfer between vehicles is also necessary. To support these efforts, NASA and companies are investing in cryogenic fluid management research, with over $250 million in government funding committed in 2020. The integration of automated couplers, flow meters, insulation, and other technologies in microgravity is a major challenge. Successful cryogenic refueling is crucial for advancing space exploration and enabling longer missions. The development of individual technologies required for in-orbit cryogenic refueling has reached a point where they are poised to be integrated into flight systems. According to Dankenich, these technologies are ready for either a space demonstration or implementation on an operational spacecraft. However, out of all the awarded projects, it seems that only SpaceX has made significant progress. With their tipping point award worth $53 million, SpaceX has a chance to complete the outlined tasks within the next 4 years. Their upcoming test involves transferring super cold propellant between tanks inside a Starship spacecraft. This is just the beginning, as SpaceX plans to conduct more complex demonstrations, with 2 docked Starships in Earth orbit. Elon Musk, the CEO and founder of SpaceX, mentioned on November 19 that the hardware for the next Super Heavy Starship test should be ready within 3 to 4 weeks. Although this projection may seem doubtful, as no rocket pieces have been moved to the launch pad for pre-flight testing, a test flight early next year seems more feasible. There are other factors that could influence the Starship launch schedule, such as addressing any issues that arose during the November 18 test flight, and obtaining a new launch license from the Federal Aviation Administration. When SpaceX embarks on the ambitious task of transferring 10 metric tons of propellant from one tank to another inside the Starship, it will mark an unprecedented feat in space exploration. However, this is just a fraction of the fuel and oxidizer required to fully fuel a Starship spacecraft in orbit, as its propellant capacity reaches a staggering 1,200 metric tons. Following the tank-to-tank demonstration, SpaceX will push the boundaries further by attempting a ship-to-ship propellant transfer between 2 interconnected Starships in Earth's orbit. According to Lisa Watson-Morgan, NASA's HLS program manager, this pivotal moment signifies the maturation of the systems and brings forth an exhilarating phase for HLS. These groundbreaking achievements serve as the fundamental building blocks that have never been successfully accomplished in orbit before, making it an incredibly thrilling endeavor. The discussion about propellant transfer is important, but we must not overlook the crucial work that needs to be done on Starship's life support system for lunar missions. SpaceX is aware of this and is making progress in other areas as well. They recently completed a ground test to confirm the reignition capability of the Raptor engine in extremely cold conditions, which is essential for extended space missions. Additionally, they have conducted Raptor test firings at different throttle settings to ensure optimal performance during descent burns on the lunar surface. While other companies are also involved in cryogenic fluid management with NASA, their flight demonstrations are still a few years away. Lockheed Martin's demo, using liquid hydrogen, is scheduled for 2025, and Eta Space is working on a long-duration cryogenic storage mission with Rocket Lab. Liquid hydrogen, although efficient, requires colder temperatures for storage and is prone to leaks. United Launch Alliance is also working on a smart propulsion cryogenic system, with a flight demonstration planned for 2026. Like Starship, Blue Origin's human-rated lunar lander for Artemis will rely on orbital refueling but with liquid hydrogen. Blue Origin's approach to cryogenic fluid management involves actively controlling the temperature of liquid hydrogen using cryocoolers, while SpaceX is using passive thermal control on Starship. Once these milestones are achieved, SpaceX will be prepared to send a crewless Starship to the Moon for a test landing. If successful, NASA will grant clearance for a crewed landing on the lunar surface during the Artemis 3 mission, marking a historic return for astronauts since 1972. SpaceX's Super Heavy booster and Starship rocket are set to undergo their next full-scale test flight, with the rocket reaching space for the first time in a recent successful test flight. This progress is crucial for SpaceX's partnership with NASA, as they are tasked with providing a commercial human landing system for the Artemis 3 mission. However, potential delays could push the mission beyond its late 2025 target. Despite not explicitly mentioning SpaceX's plans, NASA's Lakeisha Hawkins indicated that the company is making swift progress towards their next launch, which will include a propellant transfer demonstration. Jimmy Russell, a spokesperson from NASA, has indicated that the tank-to-tank propellant transfer within Starship, which involves moving 10 metric tons of liquid oxygen, is still a possibility. This demonstration is part of the 2020 Tipping Point Award terms, and SpaceX is working closely with NASA's Glenn Research Center and Marshall Space Flight Center on this project. According to Russell, NASA and SpaceX are currently exploring options for the demonstration to occur during an integrated flight test of Starship and the Super Heavy rocket. However, no final decisions regarding the timing have been made yet. That's it for today's episode. We hope you enjoyed it and learned something new. Please let us know what you think in the comments section down below. Your feedback is very important to us, because it helps us make better videos for you, so thank you very much and we hope to see you again next time.